Welcome to This Explainer. Today, we're diving right into the fascinating science of repairing our planet. It's a field absolutely packed with incredible dynamics. And, well, to kick things off, we're going to look at what sounds like an impossible ecological mystery. How did a small pack of wolves change the physical flow of an entire river? I know, it sounds exactly like a riddle, right? But to answer it, we really need to explore the mechanics of how ecosystems break down in the first place, and, much more importantly, how they actually heal.
Section 1, Ecosystems Under Attack.
So, to really appreciate the solution to our wolf mystery, we first need to confront the macro problem. Look, when rising human populations push these fragile environments right to their breaking point, we're left with this incredibly stark contrast. We see parched, cracked earth right alongside heavy industrial pollution just choking out the sky and sea. And when we break down our specific impacts, the cascade of damage is pretty extensive. Rapid population growth drives unsustainable land use, which directly causes deforestation, habitat fragmentation, and even dangerously low crop genetic diversity. You combine that with severe pollution, things like sewage runoff causing the eutrophication of lakes, and the overarching threat of climate change, and, well, these destructive forces aren't just harming nature out there. They're literally threatening our very own survival.
Section 2, The Science of Restoration.
Now, the good news is that science isn't just a bystander here. Ecological literature defines ecosystem restoration as the process of assisting the recovery of an ecosystem that has been degraded, damaged, or destroyed. I really want you to focus on the crucial word there, assisting. We aren't building a forest from scratch in a laboratory. Instead, we're just providing that initial spark that allows nature to do what it does best and heal itself. But we definitely have to be precise with our terms. It's totally vital to distinguish between a full restoration and what ecologists call an enhancement. You see, restoration is the absolute gold standard. It rebuilds an ecosystem so that it's a little different from the pristine, pre-degraded environment, addressing the whole shebang, the physical environment, the plants, and the animals. Enhancement, on the other hand, that just means restoring a few ecosystem processes or species. It's helpful, for sure, but it leaves the system far from its pristine state. Section 3, the Recovery Toolkit. So how does this actually happen? Ecologists don't just guess out in the wild. They follow a highly structured four-step toolkit. First, they assess the opportunities. Second, they improve the institutional environment, basically getting the right policies and support in place. Third comes the actual planning and implementation, getting their hands dirty. And finally, step 4 involves rigorous monitoring, evaluation, and feedback to ensure long-term health and share what they've learned. Section 4, the landscape of fear. Okay, let's look at a spectacular real-world example back in Yellowstone to answer our big opening question. Here's the historical context. Once incredibly abundant, North America's iconic gray wolves were nearly wiped out by the 20th century. Because of this, Yellowstone National Park was left without wolves for an entire century. The apex predator was completely gone, and man, the ecosystem shifted drastically because of it. But when a small number of captive-bred wolves were finally reintroduced to the park, they immediately triggered a massive behavioral shift in the local prey. The reason for this is what ecologists call the landscape of fear. Just the mere presence of an apex predator fundamentally altered the local grazing patterns. Because of this new landscape of fear, the massive grazing herbivores, we're talking the deer, the elk, and the bison, completely changed their habits. They abandoned the places where they could easily be trapped. They actually vacated the vulnerable, tight river valleys and moved to safer, more open areas where they could see the wolves coming. And this triggered an absolutely incredible ecological cascade. With the constant heavy grazing finally gone from those valleys, the riverbank vegetation rapidly recovered, and trees literally started coming back and taking root along the edges. Now, as the trees returned, they provided crucial new habitat. The regenerating forest drew in songbirds, and crucially, the thriving vegetation brought the beavers back to eat the trees. Now, beavers are famous for being nature's own ecosystem engineers, right? And they quickly got to work. By creating pools and riffle sections, they completely transformed the physical shape and flow of the rivers, multiplying the habitats available for countless other species. So let's tie all of this together by reintroducing just a single missing species, a really small number of wolves. An incredible ripple effect occurred. It changed the behavior of the elk, which allowed the trees to grow, which brought back the beavers, who then literally changed the physical flow of the rivers. A small number of wolves transformed and restored the entire ecosystem. That is restoration ecology at its absolute finest.
Section 5. The challenge ahead.
Now, while the Yellowstone story is deeply inspiring and shows us exactly what's possible, the discipline of ecological restoration faces a massive hurdle. As environmental degradation rapidly expands, humanity may soon find itself in a position where our human capital and our economic resources are simply inadequate for the sheer global scale of the problem.
We're definitely seeing a worldwide increase in awareness that we have to sustain these ecosystems simply for our own well-being. We have the toolkits, we know the science works, we've literally seen it change the flow of rivers. So I'll leave you with this final vital question. Knowing we have the science to heal our planet, will we actually invest the necessary resources before the scale of the problem outpaces our ability to fix it? Thanks for joining me on this explainer. Keep asking questions, and I'll see you next time.